Question number 66. Reaction taking place during smelting process is. In this case, 4 different processes are given here and we need to just find out that process where smelting is taking place. So smelting is the process where the reduction of metal oxide take place using either carbon or carbon monoxide. So let's check. ZnCO3 is given in the first option, that's heated to give you ZnO and CO2. In this process, there is the formation of zinc oxide. This is calcination process. The first one. Further, Fe2O3 is treated with carbon to give you Fe and CO. Yes, this is the smelting process. Further, CuS is there, oxygen is there, and it is heated to give you CuO and SO2. This is roasting process in which metal sulfide is heated in sufficient oxygen supply to give you metal oxide and sulfur dioxide gas is released. Further, we have aluminium hydroxide. It is heated to give you Al2O3 plus 3H2O. This is also the process of calcination in which oxygen is not there. Ore is simply heated to give you metal oxide. So the only option to show you the smelting process is option 2, and that's why this is the correct answer. Question number 67. The correct match of the column 1 with the column 2 is. 2 different columns are given. In column 1, impure metals are given, and in column 2, refining processes are given. If we talk about the first one, here is silicon and germanium. These are the elements of group 14 of the modern periodic table, and these are generally used as semiconductors. We need the high pure form of these elements. That's why for that we use the method of zone refining for the purification of these 2 elements. Further, we have the metals mercury and cadmium. These are the volatile metals, and for them we can use the process of distillation. So this can be matched with the 4th one. After that, we have copper and silver. These are inert metal, we can say. These are less reactive metals, and for them we use the method of electro refining. So it can be matched with the first one. After that, lead and tin is there, and in this case they have low melting point. Their impurities have high melting point as compared to them. For them we use the method of liquefaction. So it can be matched with 3rd one. It means we have matched all of them, and on the basis of this we can easily choose the correct option. Where this correct option is given, it's given here, and that's option 2. That's why you should choose it as the correct one. Question number 68. The incorrect statement for Ellingham diagram is. We have different statements given here as the different options. We need to just find out them, and we have to choose the incorrect statement from them. We know that Ellingham diagram is the plot of delta G naught versus temperature. It means this is the plot there. Now let's check what it is given here in the statements. It's a graphical representation of standard free energy change with temperature. Yes, it is so. That's why this is correct one. Further, the second statement, the graph of metal oxides generally moves upward with increase in temperature. If you look at the Ellingham diagram, you will identify that this contains the graph of metal oxide that generally moves upward with increase in temperature, and that is why this is also the correct statement. Further, it represents thermodynamic and kinetic feasibility for the process. In this case, we can say that it represents the thermodynamic feasibility for the process, but it does not tell us about the kinetic feasibility of the process, and that's why this statement is the wrong statement or the incorrect statement. Let's check the 4th statement also. The steep rise in the slope indicates the phase change. If we find a steep rise in the slope, that indicates the phase change process, and that's why this statement is also correct. And on the basis of this, the incorrect statement regarding Ellingham diagram is given in option 3. And yes, the answer is also option 3. Question number 69. The process which is not used for concentration of bauxite ore is. If we talk about the concentration of bauxite ore, Hall-Héroult process is used. It's correct. If we talk about Starpex process, that's also used for the concentration of bauxite ore. Even the Bayer's process is also used. But if we talk about Bessemer's process, that is not used for the concentration of bauxite ore. The process given in option 2 is Bessemer's process, that is used for making of steel. That's why this is the odd one out. It is not used for concentration of bauxite ore. After this, question number 70, the sulfide ore for which froth flotation process is not used commercially is. We have different options given here. We know that for the sulfide ore, we generally use the method of froth flotation. But they are asking that which sulfide ore this process is not used commercially. In this case, we can mark silver sulfide. For silver sulfide, we do not use the process of froth flotation because it is not commercially economical, which is not economical. And that's why I'll choose it as the correct option. I just want to make clear here also that if we talk about silver sulfide, for that we use the process of leaching. That's hydrometallurgy. And that's why the correct answer is option 3.